Hey guys, this is Integrated Math 3, Unit 3, Notes number 5. We can call it TOA Part 2. So here's your FLT, okay? Given your right triangle, you're going to be able to apply trig ratios in simplest radical form. So it's similar to what you guys did in the last lesson, except there's not a lot of computation. So you won't be needing your calculator for today. You will in future ones, but just keep that in mind, okay? So quick refresher, remember that TOA isn't just a funny phrase, but it actually tells you that sine of theta is equal to opposite over hypotenuse, O over H. It's a neat way of telling you what those ratios are. Cosine is adjacent over hypotenuse. And TOA, tangent of theta, is equal to opposite over adjacent, O and A. Okay? And you were taught in the last lesson to use this to find missing sides, right? So now we're just focusing on the ratios, not necessarily solving, but there are some occasions where you would have to keep in simplest radical form, which is where we want to watch out for, okay? That's the easy part. So here we go. Here's example 1. Find. Now, this one's a little bit different from delta math because we're going to do a little bit more, okay? I'm going to say find sine A, cosine A, and tangent A in simplest radical form. We'll write that down once. Everything else will shorthand, okay? So suppose the picture I gave you was this right triangle here. Make sure that you guys are labeling it appropriately. This will be A, B, and C, okay? I'm also going to tell you that this is 14, this is 17, and this is the square root of 93. Okay? So, here we go. Based on the question, we want to find sine A, cosine A, and tangent A, right? So that tells us that we're standing, or our little man should be standing at angle A. So we're right here because that's where A is. So we label our sides. Go ahead and do that and then press play when you're ready. So if your little man is right there at A, 14 should be your opposite because it's directly across from you. Across from the right angle is always your hypotenuse. And right next to you would be your adjacent side, okay? So here we go. It's not that bad. Sine of A would equal, okay? So remember that sine, is opposite over hypotenuse. So the sine of A would be opposite 14 over hypotenuse 17. Okay, let's keep going. Cosine of A is adjacent over hypotenuse. So CAH, C-A-H, adjacent over hypotenuse. And tangent of A is equal to opposite, TOA, opposite over adjacent. Okay, and generally that's how you do it, okay? Now, this notion of simplest radical form, okay? What that means, and you guys need to write this down, is that they want you to rationalize the denominator. Okay, so out of these three, which one has a square root or a radical in the denominator? So in this case, it's not sine of A, so this one you're good, okay? Cosine of A has a square root, but it's in the numerator, so you're okay. But tangent of A here is where you have a square root in the denominator, all right? So we have to rationalize it. So here's a quick sidebar. if you guys remember the shortcut, if I had something like 5 over the square root of 2 or 5 over radical 2, the way to rationalize that very quickly is you bring your radical up top over your radicand. Radicand is everything inside the radical. Okay, so here's another one. 4 over radical 3 is just, press play when you're ready. 4 over radical 3 is just 4 radical at the top, radicand at the bottom. Okay, so how do I rationalize this one right here? That's the same thing as 14 radical 93 over 93. Now, I know some of you guys say square root. You guys can say square root too, okay? You can use square root or radical interchangeably. So those are just synonyms, okay? So now we're good. Okay? So here's what I'm going to do now. Here's part B. Okay? Now instead, I'm going to ask you to find sine B, cosine B, and tangent B. Okay? So here's your picture. I'll call this A, I'll call this B, I'll call this C. 14, 17, and the square root of 93. Okay? This is very intentional. I understand it is the same picture as before. Okay? But how is this different, right? So here, you're trying to find out the sine of B, cosine of B, and tangent of B. So where you're standing is different, whereas in part A, you were standing on angle A. Here, your little man or woman or person will be standing at angle B. So here we go. Directly across from the little person is your opposite. Always across from the right angle is your hypotenuse. And right next to you is your adjacent. Okay? So go ahead and find out what sine B, cosine B, and tangent B is. Press play when you're ready, okay? Take all the time you need. Okay, so sine B is so opposite over hypotenuse. So that's the square root of 93 over 17. Notice how it's different from the other sine, right? Okay, cosine of B is going to be adjacent over hypotenuse. So TOA, CAH, so 14 over 17. And tangent of B is going to be square root of 93 opposite over adjacent 14. Do we need to rationalize any of these denominators here? Okay, so notice how there are no square roots in the denominator here, so we're good. None here and none here. So we actually don't need to rationalize any of these three. Okay? And that's it. All right, so here's part C for you. So let's say I wanted to, I'll give you this triangle here. Let's call this D, E, F. Hang on, let's do 5, 1, square root of 24. Okay. Okay, I want you guys to go ahead and find sine of F. Cosine of F and tangent of F. Press play whenever you're ready. Okay, so First step is knowing where you are. So you're standing at angle F, so your little person should go right up here. Okay, that means 1 is your opposite side because it's directly across from you. Always across from the right angle is called your hypotenuse. So that third side next to you is your adjacent. So sine of F would be opposite over hypotenuse, so OH. So that'll be 1 over 5. Cosine would be adjacent over hypotenuse, so that'll be square root of 24 over 5. And the tangent would be opposite over adjacent, so that's 1 over the square root of 24. Okay? So are these answers clean? 1/5 has no square roots in the denominator, neither does cosine. But tangent down here has 1 over the square root of 24. So what does that rationalize out to? Press play when you're ready. So that comes out to just 1 square root of 24 over 24. Okay? And that's it. All right? Does this get weird? Okay. Here's some things to think about. Here's part D. Let's do L, M, N. Okay? And we'll go ahead and do, let's see, we'll do 7 and 3. Okay? Now, LM is intentionally left blank, okay? So I'm going to ask you, what's sine L, cosine L, and tangent L? Think about how you would do this one here, all right? Press play when you're ready. Okay, so we know that L is where your little person is. Okay, so opposite of that little person would be opposite. Cross from the right angle is your hypotenuse. Third side next to you is adjacent. Okay, so sine of L is opposite over hypotenuse, so that's 3 over 7. Cosine of L is adjacent over hypotenuse, so that's something over 7. We don't know what adjacent is. And tangent of L is TOA, opposite over adjacent, 3 over whatever the adjacent side is. So the thing is, we don't have enough information. The only way to get cosine and tangent is if we know what adjacent is. So is there a way to figure out what the length of the adjacent side is? Yes, there is. So if you take a look at this picture, you're given 2 sides of a right triangle. So with 2 sides, shouldn't you be able to figure out the third? Okay, press play when you think you have it. Pause if you'd like to think about it. So everything connects with trigonometry, okay? Everything triangle related. So if you're given 2 sides of a right triangle, you could find the third one using the Pythagorean theorem. Okay, comes back, which is really a squared plus b squared equals c squared, c being the hypotenuse. So here we go. We know that the hypotenuse is 7 squared. We know one of the legs is 3 squared. So let's find out what the other leg is. Now 3 could have been for a as well, remember that. So a squared plus 9 equals 49. Okay? So a squared is equal to 40 once I subtract both sides by 9. Now that I have the square by itself, I can square root both sides. leaving a as the square root of 40. Okay? Now, here's the thing. Square root of 40 is your missing side. So we could put the square root of 40 here and the square root of 40 here. All right? Now, there's a third thing that you guys are going to have to pick up before this lesson is over, okay? So, first off, we can rationalize this. We could say that this is 3 square root of 40 over 40, okay? Now, the key word here at this lesson is simplest. And this is where we have to revisit something that we did with square roots, okay? Now, take a look at 24. The square root of 24 could actually be simplified. So I'll give you guys a quick crash course. You guys did this in IM3, but I'll refresh your memory. The square root of 24 can be broken down to 2 factors of 24. We actually did this first semester too, now that I think about it. 24 is either 12 times 2, 8 times 3, 4 times 6. It doesn't matter what you start with. I'll do 4 times 6. And 4 is really 2 times 2. And 6 is really 2 times 3. And the moment you have a pair meaning 2, you could take out that number. This is a pair of 2's, so this is really 2 radical. All that's left is 6. So what you guys need to do is go back to this example. 24, the square root of 24 is really 2 radical 6 over the 5. And that's how you make it simplest. Okay? So down here, we actually have to go a little bit further. This is really this would have to be 1 times 2 radical 6 over 24. Okay, so I'll show you the highlights just so you know what I did. I replace the square root of 24 with 2 radical 6. Okay, now on top of that, all the stuff that I'm going with you guys right now are minor details. Don't let it cloud the entire lesson. Okay, finding sine, cosine, and tangent is easy, but how do you take care of the little algebraic work? You notice that 1 times 2 here is 2, but 2 can reduce with the 24. So if you divide the top and the bottom by 2, this becomes 1 radical 6 over 12. And that is simplest radical form. All right? So let's try that here. The square root of 40, can that be simplified? All right? Well, I know 40 is 8 times 5, and 8 is 4 times 2, and 4 is 2 times 2 times 2 times 5. I have a pair here. I have a pair of 2's, so 2 is going to go on the outside. All that's left is the 2 and the 5 on the inside, which makes 10. So I could actually simplify. So the square root of 40 is the same thing as 2 radical 10. So this is 2 radical 10 over 7. Now, since 2 and 7 can't reduce, I'll just leave it. All right? Let's do the same thing here. This is going to be 3 times something over 40. The square root of 40 is the same thing as 2 radical 10. Okay? The 2 and the 40 can reduce. What would that come out to? Press play when you're ready. That will come out to 3 radical 10 over 20. If I divide the 2 by 2, and if I divide the 40 by 2, I will get what I got in green. And that is simplest radical form. Okay? I think one more ought to do it. Let me try one more. Oh, okay. So there was a square root at the beginning. The square root of 93, right? So what times what gives me 93? Press play when you're ready. So it's actually 3 times 31. But then I really can't break down 3 and I really can't break down 31. So if you notice, there are no pairs that can go outside. So that means that this is already simplest. So there's no need to change it. The thing is, you guys have to check. All right? That's pretty much it. If you have questions, let me know. But I think you guys got this, all right?